All right. So we have completed the module one. Module two, as I mentioned, we'll get back to module two once we touch base on, day one config, basics of security policies, zones, and interfaces, right? I have to set up lab like login and all is done. I didn't get time to practice because of my office work. I'll do today and tomorrow. No problem, Ram. See, the reason I'm telling you guys is because the more you do the lab, it will become easier for you, right? Uh, but no worries. I mean, I understand there are work commitments as well, so that's completely fine. Please try to do the lab in your leisure time, right? So that all of us will be on the same page. All right. So, security policies, security zones, and interfaces, until we become acquainted with these information, these will not make much of sense to us, right? What is L3, L2 deployment? What is a VVAR deployment or a tap deployment mode, right? So that's the reason we started with module three. Once module three is visited, this is more of like a overview. I mean, module two, we don't have to worry too much. There's nothing too detailed into it, right? I mean, L3, the most common deployment mode is L3 that we have seen so far in our lab topology as well. Whatever lab we have deployed, it is in layer 3 mode. So the topology there in lab guide, you'll be able to see we have used like two interfaces, Ethernet 1/3, Ethernet 1/1. Those two data plane interfaces are deployed in layer 3 mode, right? So that's right. No worries. We'll visit these deployment modes later on. So in the overview of day one config, I'd like to just quickly revise what we have covered in day one config, right? So let me go down. Right. So day one config. Okay. So in day one config, what we did, we configured interfaces, right? Then we configured zones. We configured virtual router, configured security policy, configured NAT policy. Okay. So these were the steps that we have done for the day one config. This was a very simple config wherein we have just provided access to our one of the PC which was there in our LAN environment, right? Let's see the lab topology once again. So here we go, right? So 1/3 was connected to your LAN zone, and 1/1 was connected to your WAN zone or WAN environment or ISP, whatever you'd like to call, right? And then management interface was connected to your management PC, right? Where we were able to access your GUI of this firewall. Okay. Now, uh, where is my whiteboard? Yeah, right here. So in the interfaces, we assigned IP addresses, we assigned virtual router, we assigned zones, and then we headed towards the security policy to create a very basic security rule, and wherein we allowed from a source zone to a destination zone, and everything was allowed. We were not denying anything. We were not restricting any traffic, right? And then there was a default NAT policy. Default NAT policy is anything originating in a source zone heading towards a destination zone will be NATed to your ISP interface, right? So this was an overview or things that we have covered in day one config. Today we are going to have a look at what is an interface, what all types of interfaces are there, what is a zone, what how many types of zones are there, why do we need a zone. So we are going to address all these questions today. What is a VR? Why do we need it in firewall, right? why does the firewall need a router, virtual router at all? And security policy, components of security policy, how you can configure these security policies, and what all parameters you can add to, have a granular control over the traffic. And then the NAT policy, wherein, I mean, I'll give you a very simple explanation right now, because we have a whole lot of module over there that will just go in depth with the NAT policy in detail, right? So let me start these devices. Let's first import the configuration. Okay. Yeah, Deepak, you can unmute.
So officially our class starts today, right? Like the paid course.
Yes, that's right.
Uh,
Yes.
thanks.
So
So
from, I
that's
mean, I'll share those details, right? Today I'm just covering it up. So on a very, you can call it as a day one if you'd like. And then we'll have, these labs, whatever you were able to access under the NG free labs folder. Those will be moved to the paid course segment, because that was a part of like 2 days or 3 days demo, what we are giving, right? And then apparently everything will be moved to a separate folder. You will be provided access to that particular folder. We will start on lab provisioning today or tomorrow, and we'll share those details with you, right?
thanks so much appreciated.
All right, no worries. Great. I'll today, I mean, see, all of you will have right now. There were few things that we have done in our day one config, right? Now, because for those of you who have already completed day one config, and those who don't want to repeat it again and would like to resume from today, right? What we are doing today, you can go ahead and click on import config, and then you'll be able to log in with your same credentials, and you'll land on this page, right? You will have something called as import. Now this import is the configuration which was done in the previous class, which is available to you, and you will be able to import it on the same lab, right? There are few options that you are seeing additionally, is because I'm an admin, you might not have those options to you, right? So what I'm going to do, what you will have to do is you'll have to click on import, so that whatever configuration was done in previous class, you will be able to have that configuration imported on your firewall, and then you can resume your work from there onwards, right? So you don't have to go ahead and configure interfaces and all those things. As of now, when I click on import, that configuration is imported. Let me wipe the node. If you get an error like that, just come here, wipe the node, click on import, import it. Once you import, you'll have all the configuration, including the password that was changed, right? So if you remember, we also changed the password. That is test at 123. Okay. So let me start these devices. Can you cover how we decide the zone and conduit? We will cover, Ganesh. So we'll go step by step, right? Wherein uh, first let's try to understand what is a zone. Okay. So let these devices start. In the meantime, let's talk about the interfaces. Okay. Now, I'm pretty sure all of you are working in a network environment. Okay. So everyone who's working in network environment has worked with Cisco devices, routers, switches, right? So all these routers or switches will definitely have interfaces, right? So, right. So you can have like GI 0/1, GI 0/2. That is gigabit Ethernet 0/1 interface, where 0 represents the slot and 1 represents the port number, right? Similarly to the switch, you will have similar configuration, right? Port 0, port 1, or port 1 of 0, kind of like that, right? Wherein there will be a slot. Now, again, I'm not going to go deep into why or how a slot look likes and everything. It's a simple understanding that there are ports which are present on the router or switches, and similarly, we will have ports on the firewall as well. Okay. So if you have a firewall, you will have few ports, right? Now uh, these ports will be like, you can connect an RJ45 connector, right? An RJ or Ethernet in simple words. Do we have configuration that you configure on device while taking sessions here in a lab domain? Yes, yes, Srikanth, we have that. Once the device boot, right? I'm waiting for the device to come up. Once this device comes up, we'll be able to have the same login, everything. I'll show it to you, right? So you'll just have to click on import and it will be available to you. So give it a minute. Meanwhile, this is booting up. I'll explain concept. Okay. So the interfaces will be RJ45 or Ethernet interfaces. There will be optical cable interfaces, right? Optical interfaces, or we call it SFP SFP interface. Okay. Okay. On the firewall, we will have configuration options for Ethernet, okay, VLAN, loopback, and SD-WAN, tunnel, and SD-WAN. Okay. Now, Ethernet are these interfaces, right, which are there that you see on the front panel. Okay. Let me show you the front panel of a simple box. So this is how your PA 1400 series. So this is a 1420 box, right? This is how it will look like. There will be few ports that you are able to see over here, right? Port 1 to 8, and then you can see 9, 10, 11, 12 are separately categorized. And then we have SFP ports, which is from 13 to 22. And then we have console port, and then we have HA ports, right? And then these are management interface ports, right? You can get all the details over here, wherein Ethernet ports 1 through 12. If you see this, 1 to 12 are Ethernet ports. However, out of those 1 to 12, you can see port 1 through 4 are 1 gig port, and then port 5 through 12 are 5 gig port, right? So there is a difference how these ports are categorized. Now you might be able to see 9, 10, 11, 12 are categorized separately because they have a capability of PoE, that is power over Ethernet, right? uh, Power over Ethernet ports. That is why they are categorized a bit different over here. Then if you see SFP plus ports, right? What is SFP? SFP is a simple form factor wherein, or a small form factor wherein, you can plug in a module, SFP module inside that port, and then you can connect an optical cable, and you'll get a very high bandwidth or throughput of that port. Okay. So there are, if you see port 13, this port 13 through 22 are SFP ports, right? We can see here SFP plus ports, right? So SFP is the name, and then based on plus QSFP and all those things, the speed of that port will increase or decrease based on the model over there. Okay. So you can see port 13 through 18 is 1 gig, 19 through 22 is 1 gig slash 10 gig. Okay. And then it also depends on what kind of SFP you're using. If you're using just SFP, then you'll get 1 gig output. If you are using SFP plus, then you'll get 10 gig output. Okay. So these are called as transceivers. What the modules that we plug inside these ports are called as transceivers. Okay. Uh, fine. And then remaining ports, these ports are not configurable on so HSCI ports, or these ports that you are able to see, right? HSCI port, these are layer one port, these are HA ports, management port, console port, and again, USB port is for the same if you can attach a USB flash drive. And then again, we have a micro USB for console port, and then LED indicators, right? Now, the most important are these data plane ports, right? Ethernet 1 through 12 or 13 through 22, even though these are SFP plus, but these are there on your Ethernet tab, where you will be able to configure these interfaces. Okay, let's go ahead and see if our device booted up. We'll be able to log in. Admin test at 123. So I used the password test at 123 after I have imported the configuration, right? So that means whatever configuration changes I have done in last class is present on the firewall right now. Let's get access to our management computer. Let's validate the IP address once. We need to change this 192.168 1.2. Done. Close. 168 1.1. That is the management IP address of our firewall that we have assigned in previous configuration, right? Proceed, then login. These screenshots are attached in the lab guide for your convenience. Allow it a minute. All right. So this is the dashboard. This is the default page where once you log in, you'll be landing on the dashboard, right? We will head towards the network tab. You can see these IP addresses already assigned. I did not do any configuration over here, right? And fine. So right now we are under interfaces. We were talking about uh, Ethernet. I told you, right? These many options are available over here. Uh, if you see Ethernet, VLAN, loopback, tunnel, SD-WAN. So Ethernet, VLAN, loopback, tunnel, SD-WAN, right? So Ethernet is the place where you will get your data plane interfaces, right? Whatever interfaces that I have showed you in the front panel right now, exact same interfaces you'll be able to configure from the Ethernet tab. Okay. VLAN is wherein when you are going to create any VLAN on the firewall, then you can come down and add a VLAN over here. We'll not discuss VLAN as of now. We'll see, when we'll be discussing more complex topologies. At that point in time, we'll see how VLANs work, right? Loopback, as everyone is aware, it is same the logical interface which is always on. It is exactly the same loopback interfaces that you will go ahead and configure on your uh, Cisco router switches, wherever you configure those loopbacks, right? So you can configure your loopback over here. Then we have something called as tunnel interface. Now, this tunnel interface is used in IPsec site to site. So when we'll be discussing IPsec site to site configurations, we'll come down here and configure the tunnel interface. And then SD-WAN is wherein, the SD-WAN interfaces are configured. Uh, SD-WAN is not in the scope of this PCNSE course. SD-WAN generally needs a separate license, okay, wherein you will be able to enable PAN OS SD-WAN feature, okay. But again, we are not going to discuss that but I'll give you an overview though, right? How these interfaces look like and how these actually work, right? You can see it says license required for SD-WAN to function, right? All right. We configure two interfaces, Ethernet 1/1, 1/3. 1/3 is connected to our trust zone, and 1/1 is connected to your untrust zone. Okay, let's go ahead and see what all things we have configured over here. So far, any questions related to front panel interfaces, general discussion? Any questions? Okay, all right, cool. So let's see what all parameters are available in Ethernet 1/1. Okay. Now, when you say 1/1, that means where one represents the slot and the next one represents the port number. Okay. Now, interface Ethernet 1/1, this means slot one slash port one. Smaller boxes like 1400 or PA 850, 820, 220, these boxes just have, uh, you know, uh, these do not have a modular ports that you can install onto them, right? The high chassis boxes like 7K or 5200 series firewall or 5400 series firewalls, these will have modular NPCs, DPCs, that is network processing cards, data plane processing cards, that could be inserted. And there you will get an option to select the slot, wherein it could be a slot one, slot two. Based on that, your interface number might change, right? It could be Ethernet 1/1 or it could be Ethernet 2/1, right? Based on the module that we are configuring over there. We are right now working on VM, so we do not have any additional modules to configure. So for us, it will always be Ethernet one slash anything, any port number that you're configuring, maybe 1, 2, 3, 4 or X, right? Whatever port number that we are configuring. Okay. Now, comment is nothing but wherein you can add some description about this interface. So let me write ISP interface, right? So this is to give a detail. For example, you are the administrator, but someone else is newly joined and he's looking at the configuration on the firewall. Adding a comment will make his life easier, right? Okay. So when he looks at the interface, he sees the comment. Okay, it's an ISP interface. Oh, all right. This there's an ISP router that might be connected to this interface, right? So this gives him an idea why this interface is being used. Interface type, let's see what all options we have. We have TAP, HA, virtual wire, layer 2, layer 3. Okay, so right now we have configured this as layer 3. Why why we have configured it as layer 3? Because we have an ISP router connected to it. We would like to do the routing wherein we will be able to forward the packets from, or we will be able to route the packets from our firewall towards the ISP router, right? Let it be a static route, let it be any dynamic routing protocol that you are running over there. So if anything related to routing has to be done, then we need to select that particular interface as layer 3. All right. Now imagine, okay, let's go to the whiteboard for a minute. Right. So let's say this is my PC1, right? Now, if you see, uh, this is a switch. Okay. But we have still configured this interface as layer 3. This is my Ethernet 1/3. This is my interface Ethernet 1/1. I have configured both these interfaces as layer 3, right? Now, what does that mean? That means we are not, this firewall is not participating in STP. We are not participating in STP. Anyways, firewall will not participate in SCP, but at least it will forward those packets right across whatever packets are coming as a BPDU packets or any other packets that will be forwarded across the firewall, right? So we are not gonna take any part in that STP. We are not gonna do anything, related to layer two, right? We are not participating in anything related to layer two, right? All we are doing is layer three functionality, like routing, right? So, I mean, this switch is just simply whatever frames are being received from this interface over here, it will forward it to the corresponding interface, right? Guys, just give me a second. All right, sorry for the interruption, guys. All right. So whatever layer three functionality that we are gonna go ahead and do using these interfaces, right? So in order for this interface to function as a layer three interface, we need to assign an IP address and subnet mask. Okay. A layer 2 interface will not need an IP address. If you configure this interface as a layer 2, you will not need to assign any IP address. So let's go ahead and see if we try to change it to layer 2. So you can see we need to assign it. If we have a VLAN, then we can assign it to VLAN. If we don't have a VLAN, that's okay. And then you can assign it to a security zone, but there is no option to assign an IP address, right? So a layer 3 interface, we will go ahead and assign an IP address, subnet mask, and then we will assign it to a virtual router, and then we can assign it a security zone. But if we are talking about the layer 2 interfaces, there are just two configurations. One is VLAN and security zone. Out of that, without VLAN is okay. It's not necessary that you will always have it in a VLAN. And but a security zone is important because we are working on a zone based firewall right now. We'll talk about zones in a minute, right? So advanced, here you will be able to configure the link speed, link settings, because right now I have set it to auto. So you're seeing everything as auto. You will have an option to, if you select it as up, mm, or down, right? So you can change these settings once you change it to up and then click on OK, and then you'll be able to change the link speed and duplex if you want it as full duplex, or kind of like that. Generally, no one touches these configurations unless it is needed, because auto is going to negotiate everything for you, right? In a production environment, I mean, I haven't seen nowadays that anyone going and changing the link speed and duplex of a interface so that they'll be able to communicate. That's hardly needed in production environment. Okay. And then this is for link layer discovery protocol, LLDP, if you are to configure a layer 2. All right. If we talk about virtual wire, right? What exactly? Now, again, you see virtual wire here, we can assign a virtual wire over here, and we can assign a security zone. I hope layer 3, layer 2 is clear. So I'll be moving to virtual wire. Any questions for layer 2, layer 3? I mean, there's nothing much on layer 2 part because it's just a layer 2 interfaces, similar to a port on switch, right? Nothing much there that we are going to do. No IPS address is assigned over there. Any questions related to that? Is it okay if I move to virtual wire? Anything before sorry, moving to virtual wire? All right. So what is virtual wire? All right. Thanks, Manoj. So what is virtual wire? Virtual wire is, if I say in a very layman's terminology, it's a wire. That's it, right? A wire which is virtual, which is simple as a normal cable. We'll call it as a wire. Similarly, when we say virtual wire, wherein your firewall will act as a virtual wire, right? When we say that your firewall will act, I mean, will not do any layer 2, will not do any layer 3. There won't be anything that can we make switch connected firewall interface as layer 3? If yes, it won't support VLAN, VTP, right? Yeah, VTP and all will not be supported on the firewall. We have already connected a layer 2 interface to layer 3, right, in our topology. So if you see, there is a switch, right? This is a switch, and I have connected it to the layer 3 interface on our firewall. So that is absolutely fine. VLAN, we can have sub interfaces wherein you will be able to do the tagging, right? So tag traffic can definitely come in, but again, VLAN interface will be difficult. I mean, different. We are not gonna, configure it under VLAN right now, right? Layer 3 is wherein we are doing uh, everything related to layer 3. Okay. I hope that answers your question. Do I have firewall in layer 2 or only layer 3 only in my every topology? See, Poonam, if you see today's environment, wherever you go, you will see 90% of the deployment will be layer 3. In the lab topology, we have deployed it in layer 3, but we will see virtual wire as well. I'll make a lab for that as well. You will be able to do virtual wires, how that traffic comes and leaves from the firewall. So I'll show you that. Okay. Layer 2, there's nothing much to demonstrate. I'll try to see if I can, do a demonstration for layer 2 as well. But I mean, there's nothing we are doing on the firewall, right? It's a layer 2. So there is no routing or anything that we'll be doing. It will simply be like a layer 2 interface point to point. It works on like destination MAC lookup, and the frames will be forwarded. That's it. So, but I'll see if I can do a layer 2 for you, right? But there's nothing too interesting about it, honestly. No worries. Uh, cool. So we were talking about V-wire, right? What happens is similar to a wire, right? Similar to a wire, when our firewall is in a network topology, this is my firewall. Let's say this is one interface. Let's say this is second interface, right? There is a packet coming in. There is a packet. There is a packet coming in, and then there is a packet leaving out. Okay. We are not doing any layer 2 processing or layer 3 processing, or these two piece of information on these firewalls, right? We are not doing anything related to these. We are not doing any destination MAC lookup. We are not doing any IP route lookup. Simply, always, if a packet is coming on this particular interface, it will always leave from this interface. So a wire, right? If a current is flowing in this direction, so the current will come, originate here and will terminate here always. right? Similarly, if a current is originating here, heading towards here, it will always coming from here, and it will always leave from here. So there are two things that can happen, right? One is the packet originated from this interface, it will definitely exit this interface. So for that, we configure something called as virtual wire. And this is also called as bump in the wire. Now, why we call it bump in the wire? The reason for that is, even though we are not doing any layer 2 or layer 3 processing on these packets, we are subjecting it to inspection, right? So if there is a threat, anything malicious or any such thing is found in that packet, we will drop that packet. Okay, we are gonna just simply discard the packet, so no more forwarding over here, right? It was received and then it was dropped because there was something malicious that was detected. But if nothing is detected and we are good to forward the packet, it will always exit the other interface. So it will always be in a pair, right? Whenever you configure virtual wire or a v-wire, it will always be a pair, right? So you need to configure two interfaces as v-wire. So let's say ethernet 1/1, ethernet 1/3. These two are configured together in a vwire mode, right? So we need to create an object. I'll show you, right? So uh, virtual wire, no layer 2 processing, no layer 3 processing. Simply packet comes in through one of the interface and packet leaves through the other interface. That's it. And we'll always use virtual wire in a pair, right? Where you will designate two interfaces as a vwire. All right. Let's see that in our firewall. So for the sake of simplicity, right? Let me cancel this. Let's configure 1/4 and 1/5 as virtual wire. Okay. So we'll come here, Ethernet 1/4. I'm gonna say vwire demo. We'll change the interface type to virtual wire, right? As of now, there is no virtual wire that we have created. We have to create a virtual wire over here. So there is it is having like none over here, right? Let it be none for now. There is no security zone assigned for vwire. You cannot assign a layer 3 zone for vwire. We'll see that as well. Click on advanced, leave everything as auto, click on OK. Head to Ethernet 1/5. Why do we have this feature vwire? I'll tell you, Deepak. So Ethernet 1/5, vwire demo. It's just a comment, nothing else. Virtual wire, click on OK. Okay. You can come down to virtual wire. You'll click on add. You give it any name, right? Let's give it like vwire 1. We will select Ethernet 1/4 as my interface 1. We will select interface 2 as 1/5. As I mentioned, it will always be in a pair where you need to select two interfaces, interface 1, interface 2. You gave it a name, okay? And then tag allowed, we are not changing anything. Let's leave it for a higher discussion later down the line. But by default, every traffic is allowed. Whatever VLAN tagging or whatever is coming, it's allowed. Okay. And link state pass through. This is being checked wherever whatever information is received is sent as a pass through. We are not doing any processing, right? Click on OK. Cool. Come back to interfaces. You can see the virtual wire vwire 1 is configured in it, right? When I was configuring 1/4, I just selected virtual wire and clicked on OK. Now virtual wire, now you are able to see vwire 1 over here. Why? Because I configured that over here. right? You can do it from both the places. So this is sort of a flexibility when it comes to Palo Alto, right? I can, if I want, I can go ahead and do it from here as well. Okay. I just showed you a way wherein there are alternative ways you can navigate to and configure it as per your convenience. Okay. But again, to get to that convenience, you have to practice and then understand where these things are placed so that you'll be able to access them. Right. So I had an option to configure it from here as well. New virtual wire. If I click on that, see the same screen open, right? I'll be able to create a virtual wire over here and then assign that virtual wire to that particular interface. Okay. So instead, what I did, I navigated to virtual wire and clicked on add, added this vwire and added interface 1/4, 1/5. And then you will be able to see that vwire 1 is assigned to Ethernet 1/4. Okay. Cool. Till now, I hope we are on the same page, guys. Cool. Then security zone, we can go ahead to the zone. I clicked on new rather than going to zones directly. You can see the type of the zone is virtual wire over here. Okay. We'll talk about the zones as well. But just so you know, layer 3 zone cannot be assigned to a virtual wire interface. Okay. So let's give it a name, trust V wire. So trust V. Okay. Or V wire. Click on OK. All right. Under the advanced tab, we don't have any options because actually we are not doing anything. We are just designating it as a interface. Let's click on OK. All right. And for Ethernet 1/5, let's assign a security zone of untrust vwire. Untrust vwire. Click on OK. This is assigned. There are no other configuration that I need to change. Click on OK. That's it, right? Now, even though I have created zones from here, if you navigate to zones, you'll be able to see 4 zones. Trust and untrust, these were created earlier in our last sessions, right? Trust vwire and untrust vwire I have created just now. You can see the type is virtual wire and virtual wire for both the zones, right? Let's go ahead and commit this configuration. So meanwhile, this is committing, Deepak, coming to your question, why do we have this feature? This feature is simply wherein, you know, you are introduced. So there could be like 2 scenarios wherein you are introducing a firewall in your environment for the very first time and you don't want to make any routing changes in your environment. You don't want to assign IP addresses to this firewall. You just want that you place this firewall and it starts its security inspection, right? So what you will do, you will place this firewall in a virtual wire mode in your environment like we did right now, and that's it, right? You don't have to configure any IP addresses on this interface. No layer 2, no layer 3, nothing. And even though the traffic will go through the firewall, right? So whatever is received on one interface will be forwarded through other interface. That's it. And we still will be able to do the security inspection on the firewall, right? The other case is wherein you have a specific need that needs your virtual wire to be deployed, right? There could be complex topologies where they want a firewall to be placed in a way where the traffic is just going inside the firewall, getting inspected, and then leaving the firewall, right? So, but again, that depends on the need or the requirement. I have seen various deployments wherein they have a load balancer and then they want firewalls in their path, so that the traffic gets through the firewall, inspected, and then moves to the designated server, right? That's it. So I hope that answers your question. Cool. Ideally, do we need routing enabled for firewall to be connected and be part of a network? There is no on off switch for routing, like we do in a switch, like IP routing enable, right? We don't do anything like that over here. All you have to do is configure your interfaces with IP addresses, and then they will behave like a layer 3 interface, as simple as that. And then you can have your static routes for forwarding your packets or routing your packets, or you can have a dynamic routing, but there is no other separate configuration that you have to do. Okay, these things are inbuilt into the firewall. Cool. So we have committed this. Let's go ahead and configure the policies. We will select trusted vwire. So now let's come down to talk a bit about security policy, right? uh, we just saw virtual wire configuration, how we can configure virtual wire. Now we are configuring security policy to allow the traffic which is coming on the virtual wire interface and then leaving through the another virtual wire interface, right? So we are selecting allow vwire. We just gave it a name. I'll talk about these parameters after we have done the demonstration for virtual wire. Okay. So name, allow vwire, source, trust vwire, untrust vwire. This is my destination. Okay. And then application is any, service is any, action is allow. I'm not changing anything over here. Click on OK. I'll place this on the top. Now, always remember, security policies are evaluated from a top down approach, right? You cannot have like security policy 10 was evaluated and then you went to check security policy 1. No. Always first rule, second rule, and maybe if you have 40,000 rules as well, it will go in a sequence, get that evaluated, and based on that, your traffic flow will be allowed or denied. Okay. Let's focus on virtual wire for now. I'll talk in more detail about security policy once your vwire is demonstrated. Okay, cool. So what we now, one thing you might have observed, we have configured a NAT rule earlier, right? There was a NAT rule that was configured, right? This is for trust to untrust, which is going over internet and leaving your Ethernet 1/1, right? So we are natting the traffic to your interface Ethernet 1/1, which is having an IP address of 10.1.1.2. That was for our last session. We are not going to configure any NAT for virtual wire demonstration, right? Because it does not need to do anything on that traffic. We are not doing any sort of translations, as I mentioned, right? No layer 2, no layer 3, no source IP address translation, no destination IP translation, nothing. So we don't need a NAT rule for that, right? Now, let me go ahead and actually shut down this node. The reason I'll need to add few nodes over here so that they'll be able to ping each other, right? So let me stop this. Let me add two more nodes. All right. Yes. We configured a virtual wire on Ethernet 1/4 and 1/5. Let's edit it. Eight. We will connect one of the PC on Ethernet 1/4 and one on Ethernet 1/5. Okay. Let's start these machines and let's start our firewall once again. The reason I had to shut down this firewall is because EVNG will not allow you to connect any interfaces if the device is booted up already, right? So we have to stop the machine and then connect these interfaces. Don't worry, I'll create a separate topology for all, and then there will be a lab guide again to do the VWire demonstration as well with a step by step procedure over there. Right now, we are more interested to learn the concept. So focus on the concept rather than how things are looking. Okay. But if you have any questions, do let me know. So let's see if this machines came up. Okay. Welcome. Let's give it an IP address. Properties. Uh, Let me give it like 192.168.5.1. We don't have that subnet already on the firewall. And let's click on OK. Close. Close. One ninety two 168.5.2. All right. Click on OK. Close. So these two machines are in the same subnet right now, right? We have configured it as 192.168.5.1, this machine, and this machine has been configured as 5.2. Okay. This is just a sake of simplicity, wherein this machine would be able to ping this machine, even though the packets are going through the firewall, and the firewall is just going to do the security inspection on that, nothing else. Okay. So let's see if our firewall booted up. One, two, three. Cool. Let's refresh this page. Let's see if the interface has come up. 1/4, 1/5 is up. Let's see if we are able to, let's assign the IP addresses first, okay? We close this console. This is assigned 5.1. Five dot two, right? Let's see if these are able to talk to each other. Ping 192.168.5.2. Request timed out. Let's see what's happening on the firewall. Let's take the CLI and see if the ARP is being learned or not. So that is the point, right? We don't need a default gateway because first of all, these machines are in the same subnet. And second of all, we are not going to configure any IP addresses on these virtual wire interfaces, right? So that is why it is called as vWire. We are not configuring any IP addresses. Then where exactly are we going to point these, right? So no, we are not gonna do that. Ideally, this should work as it has been configured. Let's see. Test at 1, 2, 3. All right. Let's see what's happening. Show interface all. All the interfaces are up. These are up as well. Show ARP. No ARP entries being learned. That's interesting. Hmm. Let me do one thing. Instead of this, let me place a router. So I'm not sure. Here we are not able to ping, but ideally this should work. This is how your topology, would look like. Anything heading from here to here. Let me try to replace it with router and see. Just give me a minute. One slash. Oh, 1/5. Just give it a minute, guys. Let this boot. Let's configure the router. In country interface GA0/0. No shut IP address dot 5.1. All right. I think one on the same network is problem. So, I mean, 5.1 and 5.2, if they are on a different network, then we'll need a router that will route the packet, right? And as I mentioned, we are not doing any routing on the firewall itself. That is the reason we have added them under the same subnet so that the packet will be able to reach out to the other interface, right? So I hope that is clear. 5.1, 5.2, now these two are on the same subnet, so there is no need of routing as of now, okay? In other environment, there will be two routers which will be taking care of the routing part over there. Cool. We are not doing any routing on the firewall. Yeah. The interface. So no shit. IP address 5.2. IP brief. This is assigned. See, show IP and brief. This is assigned. 68.5.2. Okay, okay, now firewall interface does not have the same IP address. Let me show that to you. The firewall interface has 172.16.1.1 and 10.1.1.2. So there is no conflict with respect to the IP address on the firewall. Zero. No. Five. Absolutely zero slash zero. Default route without a gateway. It's not a point-to-point interface. May impact performance. Okay. Let's see. Close that. In 192.168.5.2. Sorry, guys, there was some disconnection. Uh, do we committed? Yes, we committed, right? Let me check. I remember I, I did the commit, but let's see. Looks like there are pending changes. Let's see. Okay, we are logged out. Admin test at 123. Yeah, I think I missed on the commit part. Sorry, my bad. So last command that I've given is move, and I've created a rule base. I moved it to top, but there is no commit that I see. So yeah, Vignesh, I think I missed on the commit part. Thanks for pointing out. So let this commit go through. So now you can see the ping is successful, right? So my bad, I missed on a commit. So this is this happens, right? So the configuration is there in place. All I had to do was a commit, which was pending from my end, because of which the traffic was not being sent across, right? Now let's have a quick review, right? I mentioned in the beginning, there is no IP address on this interface, right? There is nothing configured, right? The packet is coming from 1/4 and then leaving 1/5. That's it. We are not doing anything layer 2, layer 3, any processing on the packet for layer 2 or layer 3 is not done. But can we see the packet in our traffic? Yes, we can see the packet, right? So we are able to see it is coming from trust V wire and heading towards your untrust V wire, right? There are other packets. Let me initiate the ping once again. You should be able to see more traffic. So the Windows machine should have worked ideally as well. Okay, cool. Let's have a detailed look over here in the traffic log as to what packet was received, what packet was sent, and what kind of processing we have done on that packet. Okay. So you can see allow, the action is being allowed. This is the session ID, and we are this action source is allow policy because there was a security policy configured that had an action set to allow, right? And the rule is allow vwire. The application is ping. Uh, don't worry about the session aged out. You can see the session end reason is end. Okay. And the IP protocol is ICMP. If you see, the source is 192.168.5.1. The port is 0. We are not doing any other changes. It was received on Ethernet 1/4 and then it was sent to Ethernet 1/5. That's it, right? Now, then we need to do certain security inspections on this particular kind of traffic. What we can do is we can assign security inspection profiles or security profiles on this particular security rule to inspect the traffic, right? Again, I'm not going to cover the security profiles right now. There is again an entire module wherein we will go ahead and discuss about all these security profiles, right? If I select profiles, you'll be able to see antivirus, vulnerability, anti-spyware. These are the security profiles that we can apply to this particular rule. And then whatever traffic is traveling or traversing between these vwire, pair of vwire, right, will be subjected to inspection. All right. So going to whiteboard, again, as I mentioned, there is nothing that we are doing on layer 2, layer 3. It's just the packet is received on one of the interface. The firewall will do the inspection and will forward it through the other interface. That's it. As simple as that. Now, you need to have a security rule to allow the flow, right? In order to allow the flow from one, between these virtual wire, you need to have a security rule or policy that will say allow from this particular zone to the destination zone, right? And again, the zones that we have configured are different. They are not layer 3 zones. They are vwire zones, right, or virtual wire zones, right? We'll talk about zones next. Let's configure. Let's complete the interface discussion first, and then we'll hop to zones. Okay. So I hope the demonstration for virtual wire is okay. Is it making sense? Any questions, queries related to virtual wire? Okay. So I'll take that as a no. Let's head to see what next we have got over here. To close this. So in the interface type, we were Sabrinathan, if we have different network also, will it be reachable? No problem, Sabrinathan. I'll explain it once again. Don't worry about it. If we have different network also, will it be reachable? Vignesh, right now we saw, right? Uh, Let me go back to our topology over here. Now, let's say I kept it in the same subnet, right? Yeah, Manoj, you'll get the recording of it. Don't worry about it. You'll get the recording. Okay. So see, the routing will always be taken care by the routers now, because firewall is not doing anything. If you want to send packet from here to here, now if it is in the same subnet, good. If it is in a different subnet, then you need to have a static route pointing on this router, that it should leave through this interface and then it should head towards this. So all the routing or whatever you would like to do will have to be done on the external routers, not on the firewall, because virtual wire does not participate in the routing. Okay. Is that okay, Vignesh? All right. So I'll just a quick review for you, Sabrinathan, that vWire is a pair of interface. We call it as a virtual wire, wherein it's sort of like, it does not participate in layer two, layer three, nothing. There is no processing of layer two information or layer three information. We designate two interfaces as a part of virtual wire, wherein the packet will be received on one of the interface and then will leave through another interface. Okay, always it is not possible that it is being received on one interface and then there are three or four interfaces and then it is leaving through any other interface. So vwire will always have a pair of interfaces assigned. If a packet is received on one of the interface, it will always exit the other interface. That is why it is called as bump in the wire, or simply virtual wire. Okay. uh, Again, there will be recording provided. You can go through the recording and see the lab demonstration what we have done. Okay, cool. Let's head towards our next interface type. So we have discussed layer 3, we have discussed layer 2, we have seen demonstration of virtual wire. Now, there are two interfaces type that are remaining, are TAP and HA. Now, HA is, again, I will give you a brief, but again, I'll not do any lab demonstration because we have an entire module that is dedicated for high availability, wherein we will configure interfaces as HA. And then based on that, we'll bring the HA2 links or HA1 links up, and we'll see higher availability functionality over there. Okay. So just to explain you, HA is wherein there is a pair of firewall. So let's say this is PA1, this is PA2, right? Now, generally in a data center, in a remote location, or wherever your site is present, right? Uh, if you have a standalone firewall, or if you have just one firewall taking care of your traffic, and this firewall goes down, your entire traffic or entire site will go down, right? And this is not desirable. This will result into catastrophic events. It will be a very big issue, right? Wherein uh, your users will not be able to reach out to either internet, or will not be able to access some of the applications which might be hosted on your data center, because your firewall is down, right? So in order to avoid such situations, we deploy firewalls in high availability mode. High availability mode. Okay. Now, high availability mode, in that, what will happen is one of the firewall will be active and one of the firewall will be passive. As in, active will be processing all the traffic and passive will be on a standby. Now, in order for these two firewalls to behave as active and passive, there will be certain connections between these two firewalls, right? So this two this is called as HA1, and this will be HA2, and these are like HA ports, or HA connections, right? Now, what happens is if you see this front panel right over here, we don't see anything as a high availability port, right? HA1, fourth one is HA1A and HA1B port. Okay, let me see. You see these two ports, right? HA1 and HA1A and then HA1B. That means your backup. Don't worry about those backups and everything. So these are two dedicated ports. Sorry, Krishna. Yes, hi, Krishna.
Yeah, how does we segment the traffic on virtual wire? Like we
We
can
don't
use the
segment.
VLANs if we
No,
want.
we don't do any segmentation. That's the whole point of EWire, right? It's just a
Okay,
wire. We are not doing
okay,
anything on that. No segmentation, no nothing. It's just traffic is so if there is a wire, right? What happens through a wire? The current will flow. You are not doing anything on the wire. If you need to do anything, you will be doing it on the end devices, right? So our
okay,
firewall will not do any layer 2 or layer 3 processing, no segmentation, no nothing on the firewall. It's just gonna do security inspection on the packets being received and sent across. That's it.
okay.
That's the whole idea. Okay. All right. So yeah, there are some ports which you can use for HA, which are already a dedicated port, right? But sometimes you don't want to use that port, or sometimes those ports are not available on the box. For example, if you see a PA 220 box, right? You will not have a dedicated HA port for that particular box, right? Then you can go ahead and use your data plane interfaces, which are used for processing the traffic, as an HA port. Once you change it to HA port, it cannot be connected to any other data plane traffic. It will be dedicatedly connected, dedicatedly used for high availability, right? Wherein it can be used as a HA1 port or HA2 port, right? But the type of that link or port will be HA. All right. So in our case, this, if I designate this as HA port, then I'll be able to use this. You can see there are no settings at all because there is no IP address that you will be configuring from here. There is nothing that you'll do, right? All you will do is designate that as a high availability port, because then this port will, and again, this port, this, let's say this is 1/2, this say let's this is 1/2. Okay, this, both the sides will be type HA. Okay, and similarly, let's say this is 1/7, 1/7. This type will be HA, this type will be HA. Cool. So both the sides has to be HA, right? It's not possible that you have one of the interface over here on PA1 as HA and the PA2 will have as layer 3 and they'll work. No, both the firewall should have interfaces configured as type HA so that the high availability links will come up. Okay. So that is the use of HA, wherein we will see this, how we will configure it and everything when we'll come down to our high availability module, right? Wherein we'll discuss about the modes, active, passive, active, active. We'll do a lab on active, passive and see the failovers and everything. But for now, I think this is good enough explanation about HA. Any questions over here? All right. Uh, yeah, Salman. Yes, Salman. You can unmute. You're not audible, Salman. Salman, sorry, I'm not able to hear you. You can do one thing. You can just type in the chat if that's okay, because your audio is. I'm not able to hear you. All right. Okay. Yes, Sabrina, the active and passive is for the high availability, where active firewall will be processing the traffic when it is active, the moment the firewall goes down, it will fail over to the passive firewall, and the passive firewall will become the active firewall, and the traffic will be processed by the active firewall. Okay. Uh, High availability port checks the traffic as per firewall rule. No, no. So this is not a data plane port, right? Anymore, it will become a high availability port. It will not, we will not have to define any security rules or any other parameters in NAT or anything, right? No policies will be uh, impacting or affecting the traffic flow of the HA links. Okay. So this sort of becomes a part of the management processing. This gets detached from your data plane processing. Okay. All right. So no security rule evaluation for HA ports. All right. Good. All right. Now coming down the last two PA devices located on the same location. Yes, Salman. So these, see, I mean, 99% of the time, that is what I have seen in the deployments, where those two firewalls will be on the same location and they will work as active passive. There is a possibility, I mean, they can be geographically distance apart, but that is not a very good design, trust me. Okay. Because again, the HA connectivity has to be very fast. The failover might not be seamless, and then again, that could be challenging. But it is possible. You can route the HA1 link connections and then things, but not a very good design. So always active passive firewall, 99% of the time you will see they will be even present in the same rack stack. Okay. I hope that answers your question. Good. Next type of interface is tap. Okay. Now, again, on the tap, you can assign at the max a security zone. There is no other configuration that you can do for uh, tap interface, right? Now, if I go ahead and click on new zone, do we need set timers for both firewall for HA pairing? Uh, the timers are default. You can change them if you want, but there are timers and everything already configured, Gopinath. So you don't have to actually manually interfere unless you want a very fast failover, like sub-second failover and all that. But most of the time, the aggressive timers or the recommended timers will be present. But you do have an option where you will be able to modify those values. Okay. So now you can see the type over here is tap, right? If I go ahead and configure an interface as, no worries. If I go ahead and configure the interface as tap, and then I need to assign a zone, and then you can see the type of that zone will be a tap, right? It will never be a layer 3 or any other zone, layer 2 or virtual wire zones. No, it will always be a tap zone because the interface type is tap. Okay. Now let's see why do we need that tap zone altogether. So again, generally you will not see tab deployments in any production environment, not needed, right? But for example, you have a company wherein you are planning to buy a PaloAlto firewall. But before that, you would like to understand what are the capabilities of the firewall, how good that firewall is. You have a security solution already deployed in your environment, maybe Sonic Wall, maybe Sophos, any other firewall, and the PaloAlto guy says, okay, I'll do one thing. I can deploy a firewall in your environment in a tap mode. In that tap mode, we can give you the visibility alone as to what exactly are the what is the traffic that is flowing in your environment, and what are the threats that we have been able to identify, and then you will be able to compare that report with your existing security solution. So this will give you an insight as to how powerful the platform is, right? So generally what will happen is you will have a maybe a distribution switch, right? So I hope everyone is aware of three-tier architecture, wherein there will be a core switch, then there will be a distribution switch, and then there will be access layer switches, right? uh, let's say this is a distribution switch. I'm trying to place it over here for the sake of simplicity. It is not any hard rule. You can do it with any switch which has the capability of port mirroring, right? So let's say this is my switch. This is my switch, okay? And all your corporate traffic passes through this switch, okay? Maybe to internet or anywhere, right? Internet, my primary data center, or remote site, anywhere, okay? I'm not worried about that right now. And the switch over here, what we do, we configure one of the switch as a mirror, right? And then we will connect that to the PA firewall, okay? The PA firewall, the interface that it will be connected will be a tap mode firewall, tap mode interface, right? So this interface, whatever interface you are connecting that mirror port, will be in a tap mode, okay, or tap type, right? So the interface type will be tap. What will happen is, this switch, because this we are doing a port mirroring over here, all the copy of this traffic, whatever traffic this switch is seeing, it will make a copy of that traffic and will forward it through this mirror port to the Palo Alto firewall. The Palo Alto firewall will do a security inspection and then drop the traffic. That's it, right? We don't have to do anything apart from that, because we are not forwarding the traffic. We are not participating in any routing, nothing. We just need to create a visibility. We just want a visibility on the traffic as to what kind of traffic and what kind of threats are there in our environment and what kind of applications, a whole detailed report, right? And based on that, then they will be able to compare or contrast two security solutions, or to understand what kind of threats Palo Alto firewall will be able to protect their environment from, right? So this is a very simple deployment, nothing too critical over here. And again, I don't see any uh, you know uh, point in doing that lab right now. But again, we will do that lab definitely when we are sort of like discussing our module 2, where we are going to discuss layer 3, layer 2, and tap mode deployment modes, right? Virtual wire we have already covered, but no worries, we'll go through it once again just to cover the module. All right, so this is what your tap interface does. It does nothing. It just helps the Palo Alto to receive the traffic. The Palo Alto firewall will process the traffic, security processing will be done, and then the packet will be dropped. You'll be able to see the logs. You will be able to see ACC dashboard, that is your application command center. You'll be able to have visibility onto the thread, on the traffic, on various other features of that, or the components of that traffic or applications over there. All right. So this is about the tap mode, guys. Again, as I said, we will try to do a lab when we are discussing our module 2, where we have this deployment modes, right? But for this interface type discussion, I think we are good. Any questions, guys, over here for the interface type? Uh, yes, span port, yes. So that's what is where the port mirroring happens, right, Vignesh? So that is where you will be connecting it. Is CAF functionality to analyze the threads traffic before site? Not necessarily. You can connect it at any point wherever your traffic. So what we are doing is, you have an environment where your traffic is already working, and then you configure either the switch or anything that can forward the copy of that traffic to the Palo Alto firewall, right? So it can be before site if you want to investigate in that way. It could be in the site itself. It could be a data center, right, where your traffic is coming and leaving. It could be anywhere, wherever you want to have that visibility. That is the point. Uh, and to write security rule based on this analysis. So again, when we have tap mode, right? Tap mode, we are gonna drop the traffic apparently. So we don't generally the one that you're talking about, right, is wherein what you do is you deploy your firewall with your existing solutions, right? And then you create a security rule with allow any, wherein every traffic is allowed. Now, what happens is because every traffic is allowed, you will have that visibility. And again, that is, it could be a layer 3 or layer 2 deployment, not necessarily a tap mode. Tap mode might not help you with writing the security rules well, because you will have to identify the source zone, destination zone, a lot many things has to be done. So what you're talking about is wherein you deploy your firewall along with a parallel existing security solution, and then you create a security rule that will have allow any kind of rule, and then all the traffic is allowed through the firewall, but that will give you a visibility as to what kind of traffic was received and what kind of traffic was forwarded, visibility and everything, right? But tap might not be a very good idea for that. And once you have that visibility, you will see these applications are flowing through my environment. Okay, I don't want to allow YouTube. Let's go ahead and create a security rule above it where we will say deny YouTube, right? So whenever you see a YouTube traffic, the first rule will be deny YouTube. YouTube traffic will be denied. When you see Facebook traffic, there is no rule for Facebook. It will again take the second rule where it says allow any, and then that traffic will be allowed. Similarly, you can go ahead and building on top of it, right? Uh, this span port to be done in L2 switch or L3, any switch. I mean, we are concerned about the copy of traffic coming down to us. If you talk from PaloAlto's perspective, I mean, I am not bothered if you do it on any. If you have a device that can do a port mirroring and forward the traffic to me, I am okay with that. I am not considered if it is a router, if it is a switch. You have altogether a new device that is capable of doing that. Good, but if you ask me, I am looking from PaloAlto's perspective. I am receiving the traffic on my firewall on a tap interface. That's it. That is good enough for me. All right. But practically speaking, you can do it. I mean, generally, your core switches or your distribution layer switches, which might be core switch would be a good idea. Reason being, it acts as a entry and exit point for your traffic, right? So core switch could be a good idea where you would like to place this device in a tap mode. Cool. Which Cisco Hirschman support this span? See, Cisco supports it. I'm not sure about Hirschman. I'm not really sure. There might be multiple vendors, but it is a very common functionality. I guess most of the switches out there should support it. Okay. If a firewall is deployed on tap vWire, can they be used for other usual functionalities? So one of the interface could be tap interface. Rest of the interfaces could be normal layer 3 interface, and then you can use it for other functionalities if you want to. That should be as good as, I mean, that should be fine. There should not be any issue with that. Cool. All right. All right, guys. I think we took a lot of time in this interface discussion. But again, there was a demonstration, right? Virtual wire. Cool. No worries. Let's go ahead and talk a bit about zone. Let me see the agenda. Just give me a second. So we have talked about interfaces and interface types. This sub interface, guys, we'll do it in a lab, right? We will see that when we will be configuring VLAN. But as far as interface type discussion, we have covered it. All right. uh, Interface management profile I have to talk about, and then zones, and then security rules. Cool. I don't think we have that much time today, but I'll go ahead and cover the zones, right? Because I think you now have a fair understanding of interface types, and based on that interface type, whatever an interface type is, the corresponding zone will be attached. But before that, let me ask you guys a question. I have explained quite few things so far. What do you understand by a zone based firewall now? I mean, we have seen, right? We are assigning a zone whenever we are configuring an interface, and interface is where you are actually receiving the traffic, and then you define a security policy wherein you allow, or from a source zone to a destination zone, either you allow or deny a traffic. Now, a simple question to all of you is, Can you please let me know what do you understand by a zone-based firewall? It's an open question to all. Segmentation like VLAN in L2. Yes. Layer segregation. Poonam, can you elaborate on that? Layer segregation, I didn't get that part. I mean, how are we segregating on the basis of layer? Yeah, guys, come on. I mean, it's okay to be wrong. That's fine. Based on layer, what we have, not very accurate, Poonam. I'll give you an idea. Don't worry. Zone is a collection of computer devices sharing common security requirements. Fair enough. That is correct. Anyone else would like to give it a go? Grouping of similar security requirements is zone. Good. Traffic routing, no, not really, Nagarajan. I mean, uh, I can try to just justify that, but not really. Okay. So traffic routing, I don't think so. Based on the zones, the policy aggressive will be varies. But the question itself is right. What is a zone-based firewall? Zones can be segregated horizontally and vertically, or so that is again how you segment your environment, right? So that's not really the answer for the question, I would say. Easy management of traffic can be achieved using zones. That's right, Vignesh. That's right. All right. Zones, accessing different zones. Manoj, yeah, I mean, not a very clear answer though. I mean, that is what we are trying to understand, right? What is a zone-based firewall? Cool. No worries. Great, guys. Yeah, that's right. DMZ or outside zone. That's right. Uh, great. This is really good. Thank you, guys. Let's come down to the discussion. Thank you. Uh, if you say you don't know why this Microsoft is lagging, this is my PaloAlto firewall, right? Now you have your environment wherein obviously you are very well aware of LAN. Okay. Now when I say LAN, definitely there is no physical thing as LAN, right? LAN is what? It's a terminology that is meant as local area network that gives you an understanding of identification of your network, right? So if I say LAN, then you are okay, this is my internal environment. Definitely we are not talking about internet. So everything which is there inside my enterprise will be termed as LAN, right? So this is switch. So this will be my LAN, right? This is my understanding. This is what we have been taught, right? When it comes to Palo Alto, similar to this LAN, right, which is just an identification of the network segment, we identify a zone, right? Now, this LAN, I can call it a LAN directly on the Palo Alto firewall. No one is going to stop me from that, right? If I say I want to create a zone named as LAN, fine, I can do that, right? It can be a layer 3 or whatever zone that, again, that is a different thing. But LAN would be the name of the zone that will be identifying the traffic coming from that particular area or segment to my interface, right? Now, zone will always have interfaces assigned to it, right? So if this is Ethernet 1/1, and you assign a zone as LAN. Okay, cool. No worries. You can have Ethernet 1/2 and then assign that interface as well to LAN. That means what? Your one zone can have multiple interfaces. I can have another interface, Ethernet 1/3, and then assign it to LAN. You will say, why will we do that, Amol? Simple. My LAN might have further segmentations like administrative section, executive section, account section, and they are coming from different switches, and I need different ports on the firewall, but I want the same security policy enforcement, right? So I want the same security rule to allow the flow from accounts to internet, or maybe executive to internet, or maybe administrative to internet, right? So I want just one rule. I don't want several other rules and creating different zones. So I can have multiple interfaces assigned to the zone. Cool. And this could be any type of zone. I'm not talking about the type as of now, right? So a zone is actually a combination of interfaces wherein a traffic would be received, and then you will be able to enforce your security based on that, right? Now, I call it a LAN zone, but this might be an ISP router connected over here, right? Firewall does not have a mechanism to determine, you named it LAN, but now the traffic is coming from ISP. This does not look right. No, firewall will not be able to identify that. This is your understanding, so that things become simplified for you, right? How you're gonna name the zones, how you're gonna segregate or segment the traffic based on this, and then you'll be able to write security policies, right? So zone is a collection of interfaces together wherein you will be able to enforce security policy. Okay, this is what is called as and when you enforce security policy based on zones, then that will be called as zone based firewalls, right? I mean, that is the terminology that you'll be using for zone based firewalls. Cool. So we have like a LAN. You can give it a name in the industry. They will be using trust, untrust, or inside, outside. And then some of you might have heard of DMZ, right? Which is demilitarized zone, where most of your public servers will be hosted, right? So uh, then you can write security policy to allow traffic. Let's say now, let's try to visualize this. Switch. I'm not sure, guys, why this is lagging this much. Sorry for that. Please bear with me. Okay. So trust. And trust. PA firewall, right? Now, both. And then there could be a server. This zone could be DMC. Okay. So now you can segregate the traffic. Now, let's say this is Ethernet 1/1, 1/2, 1/3, right? Now, if you want this trust, we can add another. I'm using switch. You can directly plug a PC. Not really a concern. 1/4, and then, right? So you can see now we have segmented it like this is my trust, right? This is my untrust. And this is my DMZ. But you need to understand, guys, the trust name is provided by me, right? Firewall does not understand that. And again, how many interfaces will be a part of that trust? It totally depends on me and how I would like that traffic to come down to the firewall, right? Now, if you define a policy that allow traffic from trust to untrust, right? Now that will allow all the traffic coming on Ethernet 1/1 and going to 1/2. At the same time, it will allow the traffic coming on 1/4 going to 1/2, right? Because 1/1 is also a part of trust zone, and 1/4 is also a part of trust zone. 1/2 is a part of untrust zone, right? So when you write a policy, you need to understand how the traffic is going to come on which particular interface, and how are we going to write those rules to allow the traffic. General case for public servers would be you will be allowing the traffic from untrust to DMZ, right? So you need to be very careful on which interface your traffic is coming on and which interface it is going, and based on that you need to enforce a very granular security so that something does not go unchecked, right? So in this case, if you have to allow traffic from untrust to DMZ, you will write a security policy with source zone and destination zone. Source zone will be your untrust, destination zone will be your DMZ, right? And then action will be allow. Cool. Any question, guys? I think this is good enough. Intra trusted, inter untrusted. These are default rules. We'll talk about that security policy, Salman. When we are talking about the security policies, right? We'll discuss what are those intra zone rules and what is the inter zone rule. So generally, we have two default rules. I'll discuss about that. What is the difference between segmentation and segregation practically? How and what network devices are placed respected to that? See, this is generally a networking topic, right? Not related to network security. Segmentation is wherein how you would like to enforce your security in a very granular fashion, right? Now imagine you have thousands of BC and you name it as LAN, right? That becomes very difficult to sort of for example, now let's say out of those 1,000 PC, one of the PC got infected. Now that PC can travel laterally and all your 1,000 PCs can get infected, right? So what we do, we call it something as segmentation, that you isolate it. Similar to a VLAN, right? Where in a VLAN, you do a segmentation on a switch where traffic belonging to one particular VLAN will only be able to go to the same VLAN unless there is a inter VLAN routing being done. Similarly, a segmentation will restrict the traffic to one particular segment, and then again from communication between two different segments can be achieved using routing devices or any network communication devices. Okay. Segregation is wherein you are now a simple example of segregation I can give you is a load balancing, wherein you have a load balancer and you have multiple servers over there segregated as one. They are providing you the same services, right? Wherein they have all the same application running. It's just one of the server went down, still you have multiple servers available to you catering to your service, right? So that is what you can get an idea based on that. But again, these are like networking concept, not really coming down to the Palo Alto firewall. DMZ and untrust difference. See, untrust is where it's, I mean, as I said, these are names. When you say from Palo Alto's perspective, general industry term is wherein untrust is where I have a public internet or everyone has that reachability, right? So anything coming from internet, we call it as untrust. We give it a name as untrust, right? You can give it as outside as well, no issues. You can give internet. You can write that name of the zone as internet as well, no issues. The reason we give it as an untrust because that is a public domain network. We cannot trust it, right? Because all the bad actors and everyone is sitting out there in that public domain. Okay. And DMZ is like demilitarized zone where my public server, which I want to host, for example, Google will be hosting their servers in a DMZ zone, wherein we are users, we are able to access your Google server going through a firewall and then being able to access their services, which are publicly available to us, right? So that is what is your demilitarized zone. Can we use different templates, say a LAN template, WAN template, and assign same Palo Alto interfaces? Uh, I you are talking about when you say templates, Srikanth, are you talking about Panorama? Um, can we use different templates, say a LAN template, a WAN template, and assign some Palo Alto interfaces as LAN and WAN, and call these templates those interfaces to have a common security rule? Uh, See, I mean, this actually question got twisted. I understand what you're trying to say, but the question in itself is wrong. Okay, so templates will hold multiple configuration wherein you can have all the, so one template you can define all the interfaces, and then it becomes a part of your template stack, and then you can define zones as well, and then that zones will be referenced in your security policy. I would say rather wait till we discuss Panorama, because again, if I go right now, everything that I have taught will get messed up, right? It will get very complicated in your head. So I would suggest just wait till that part. Reason being, it will get messy if we start discussing on that, right? Why DMZ called as demilitarized zone? Demilitarized zone because we are allowing public access, but at the same time we are enforcing security, right? So demilitarized in the sense like uh, public access is allowed, right? That is what is demilitarized zone, but at the same time we need to perform security inspection over there, right? Can we have VLAN in zones? I don't think so. So if you add a zone, this is where I'm coming to, right? We'll talk about that, Ganesh. I'll show you the types of zones as well over here. Okay, but no, there is no VLAN zone. If you see, we have only these zones: tunnel, layer 3, layer 2, virtual wire, and tap. That's it. Okay, layer layer 2 also has a zone, and virtual wire also has a zone, right? Uh, cool. So let me show you guys how many types of zones we have. Uh, we have like we have already seen virtual wire zone, right? And again, please understand, uh, you if you have same name, for example, let me show you this. I have given the name trust, and then I have named it as trust vwire. If I give this name as trust, it will take, because the type is different, right? Layer 3 and virtual wire, these are two different type of zones. Then again, you need to be you need to be sure that you are referencing the right type of zone in your security policies. Now you can see, if we go back to our policies, we have two rules: allow vwire and allow any. We see trust vwire and trust vwire. These are your vwire security zones, right? And then you have your layer 3 security zones. I can call these as well here, right? If you see, so you can have a security rule with a combination of layer 2, layer 3, and let me do a commit for you. So we can have a security policy with a combination of like layer 3 and vwire zones, or other zone types. You can call them simultaneously. Sorry, my bad. These are incompatible, right? So sorry, my bad. I'll take my words back. It does not work. Okay. So if you have a source zone as a security policy, in a security policy as a layer 3, then the destination should also be layer 3. You cannot have a vwire or any other type of zones over here. Sorry, my bad. I'll take my words back on that. So this will not work. Okay, let me remove them. Untrusted vwire. Okay, but you need to be very careful when you're writing your security policy that appropriate zone types are selected. Now if I now we just saw that the commit will fail, right? If I select over here, now if I go over here and source, if I delete this, if I add trust vwire, I'll click on OK. Let's give a commit now. The commit will fail, right? So we need to ensure that they have same security zones. So we can see zone type trust vwire of type vwire and to zone untrust of type layer 3 are incompatible. Now let's see one more curious case. What happens if I give them the same name? Will it take or not, right? Let's change it. Trust. It says trust is already in use, right? That means you have a trust security zone. It's layer 3, but you cannot have any other zone with the same name wherein Even if the type is different, the name cannot be same. Okay. If you change it to tab, let's see if it takes it. Click on OK. It took it, right? Let me do a commit. Let's see. Oh, sorry, my bad. I didn't change the name over here. Trust. So trust is already in use, right? So you cannot have two different zones with the same name, right? You will have to have a different name over there. And then again, based on the type of that particular zone, you need to write the security policies. You need to be very careful while writing the security policies. Otherwise, it might not work as expected, what you are trying to achieve, right? So layer three zones, then I mean, if you have source as layer 3 zone, then the destination will be a layer 3 zone only. If you have a source as virtual wire zone, the destination will be a virtual wire zone. Correspondingly, layer 2 on both the sides. Okay. Let me delete this. Cool. All right. Let's see what all things are there in a zone. Okay. So first thing, that you give a name to a zone, and then you have something called as log setting, right? Now these log setting are different than the log forwarding profile that we have. We'll talk about it. I'm saying the name right now, but don't get confused with that. We have something called as log forwarding profile, wherein the logs on firewall will be forwarded to a different syslog server or any other server for that matter. But these log setting is specifically used for a zone protection profile. We will discuss zone protection profile in discussion of security profiles as well, right? So there are certain security profiles that you can attach in a security rule, and then again there are certain mechanisms that you can enable for a zone protection or DOS, that is your distribute denial of service attack. DOS protection, right? So we have a DOS protection profile. We'll see that as well. So for this zone, you need to give it a name. If you would like, if you have configured a zone protection profile over here, then you can give a log setting, provided you want that zone protection logs as well to be forwarded to a different syslog server. Okay. And then you need to specify the type of that zone. It could be a tap, virtual wire, layer 2, layer 3, or tunnel. Now, tunnel, as I mentioned before, it is used for IPsec. Generally, if you have an IPsec site-to-site configuration, there you'll use a tunnel, and then you can attach a zone to that tunnel interface, so that you will be able to configure a security rule that will allow or deny that traffic in that IPsec tunnel. Okay. Layer 2, as we discussed already, again, it will act as a layer 2 interface, wherein you can define the zones, and then you can go ahead and configure security rules based on these layer 2 zones. Okay. Layer 3, we have already seen layer 3. We have been doing layer 3 from maybe like day 2, right? We are dealing with layer 3 only most of the time. This is the most common type of zone that you will see, uh, depending on the deployment. And then virtual wire, we just saw a demonstration of virtual wire, wherein you can configure virtual wire zones, and then you can create a rule to allow the traffic between virtual wire zones. Okay. Tap, I already mentioned, you configure a interface as tap and then assign a tap zone to it, wherein a span port or a port mirroring device is forwarding a traffic to your firewall, and then the firewall will be doing an inspection on that, and then that particular traffic after inspection will be dropped, right? So again, when you are doing this is very rare. When you are doing a tap deployment, in that case, you can use a tap zone. Now you can add your interfaces over here, right? Whatever interface you would like to assign to this zone, you will be able to reference these zone interfaces over here. Right now, we are not able to see any interfaces because none of the other interfaces are provisioned, right? They are in a disabled. I mean, we have not enabled them as of now. So you can see this is a gray. Green color means this interface is up. This interface is up. So these interfaces are already assigned. That's the reason you are not able to see any new interfaces or additional interfaces inside that particular zone. However, if you click on trust, you'll be able to see that interface Ethernet 1/3 is assigned, right? And you can assign multiple interfaces as we discussed, but always remember the interface itself can be a part of only one zone. Interface, like Ethernet 1/3 cannot be a part of like trust as well as untrust. Okay, please do take a note of that. This is very important. Again, I mean, it is not as if like you will be able to do it, but general interview questions like how that could be. I mean, we want the same interface to be a part of like trust and untrust. Is that possible? No, that is not possible. And an interface will be a part of a single zone, but a zone can have multiple interfaces in them. Okay. Then we have zone protection profile. We'll talk about this in our security profile discussion. We have user identification ACL. This is used for allowing or denying certain type of users. We have a process. Again, we have a module for user ID. We will see how this we can use. Device ID. Again, this is generally used for IoT, wherein you have a device ID generated. Based on that, you will be able to identify a device. So you need to collect this statistics. What is the device ID that is being coming, and then based on that, you will be able to allow or deny on the zone itself, because this is an ACL, that is access control list. You need to provide an include list. Don't worry about all this, guys. This is just I'm giving you an information. We will see user ID part. Device ID is an IoT part, not really needed. We'll see. I'll try to give more illustration or explanation on that down the line. But trust me, hardly these are used, right? But user ID ACL, yes, wherein you would like to restrict certain type of users coming to a particular zone. It might not make much sense to you right now. When we'll be discussing user ID, this will make more sense. Okay. So generally we provide include list or exclude list. Okay. You have to enable user identification so that user ID information will be collected for the traffic that is coming on that particular zone. And then based on that, you will be able to allow an include list or exclude list on which, you would like to sort of like don't want to run the user ID process, right? So a subnet which is coming, maybe 192.168.1.0/24, we want user ID to be users to be identified if they are coming from this subnet. But if it is coming from 10.1.1.0/24, do not do user identification. All right. So again, there is not much configuration. You will be always touching the name, type of the zone, and then interface. That's it for now. Enable buffer protection is by default enabled. This is to this is generally used to protect your buffer from like attacks, right? Wherein you might have heard of buffer overflow attacks and these kind of things. We'll see that. We'll initiate few attacks from Kali, and we'll see. Generally, the capacity of the box is very large, but we'll try if we can enable that error. But definitely, we'll be able to see the logs, right? And then enable L3, L4 header inspection. This is related to the packet processing, wherein if you'd like to inspect the L3, L4 for maybe like spoofed IP and those kind of things. So we'll see this when we will be discussing the zone protection profile. Okay. Cool. So this was about zone. I think I have already exceeded like 20 minutes for today's session. We have covered interfaces, zones. These were very important aspects of any deployment. So that's the reason, I mean, it took me a bit of longer amount of time. At the same time, we have done a demonstration for virtual wire. Tomorrow, we will cover virtual routers, and then we'll head towards the policies, right? So security policy. I think we are good for today. Let me stop recording.